Hello students, how are you all? Hope you are all doing good. Today in this video we are going to discuss about the angles formed by two lines due to a transversal. And before that we have to know what is a transversal. Here in this chapter you are given an example where you are given two lines M and N intersected by another line L at distinct points, okay, at distinct points. So here L is the transversal for the lines M and N, okay. And you can see four angles are formed at each points P and Q. P, the point where this L intersects the line M, okay, and Q is the point where this line L intersects the line N. So P is the point where the line L, transversal L, intersects the line M, and Q is the point where the transversal intersects the line N. And you can see at P and Q each four angles are formed, okay. See here 1, 2, 3 and 4 angles are formed. Likewise you can have here for four angles are formed, other four angles are formed at Q also. Now see, if you take this as the interior part, that means between the lines, between the two lines, if you take as the interior part, the rest are the exterior part, and the angles containing in the interior part are the interior angles, and that is why this angle 3, 4, 5 and 6 are interior angles and rest are exterior angles. What are exterior angles here? 1, 2, 7 and 8 are exterior angles, okay. 1, 2, 7 and 8 are exterior angles. So these are exterior angles, okay. 1, 2, 7 and 8 are exterior angles. 3, 4, 5 and 6 are interior angles. Now they have been given some names, okay. They form pairs of angles, and this, see here, they form some pair of angles when a transversal intersects these two lines, and we have got these names before also, okay. Check the names: corresponding angles, alternate interior angles, alternate exterior angles, and interior angles on the same side of the transversal. So at first we are going to learn about corresponding angles. See here, so these two are lines. We are not considering the parallel lines here now, okay. We will consider only for any two lines. They may be they may intersect when they are extended, so we are not talking about those. At first let us learn about this, okay. Now what are corresponding angles? Now look at here, corresponding angles, say this angle and this angle are corresponding angles, okay. Then we have this angle and this angle. So what are corresponding angles? Actually, when the angles are when the angles are on the above part of the line, that means if you see this angle is on the above part of the line, okay, the other angle should be again above part of the line, and it has to belong to the other line. So this is the angle on this line, say it was M and it was N, say, okay. So this was this angle. So for this angle is above the line, so we have to take another angle which is above the line, which belongs to N, and it has to be on the same side of the transversal. So we know, if you see, this is the only angle possible, so these two are corresponding angles. Likewise we can see this angle and this angle are corresponding angles. Okay, above part. Now again, if you see corresponding angles, this part and this part, when we are going to see the lower part, when you check the lower part, this belong to the lower part, this angle belongs to the lower part, and this also angle, this angle too belongs to the lower part. So these two are again corresponding angles, and this angle and this angle, okay, belong to the corresponding angles. So you can see, if I'll draw again, if these two are the lines, so which are the corresponding angles? This angle and this angle, okay, then this angle and this angle, corresponding angle, above part, then we have this angle and this angle, lower part, and this angle and this angle. These are the corresponding angles. Okay, these are the corresponding angles. Now about alternate interior angles. Say these two are two lines, this is a transversal. Now alternate interior, you know it will be within the two lines, region within the two lines, so it has to be interior and it has to be alternate. So alternate means, you know what, which angles it will take. This is in the interior part, the other alternate will be what, here. Okay, so what we are discussing, alternate interior angles, alternate interior angles. Okay, then we have this and this angle are alternate interior angles. Alternate means, you know, like cross. They're alternate means like cross. They're crossing the transversal on either side. Okay, for corresponding it has to be on the same side, but in case of alternate it has to be on the, it will be on the either side of the transversal. Okay, then same way we have say these are two lines, okay, and this is a transversal. So all alternate exterior angles, so exterior, you know, it will be the exterior part and it has to be alternate. So which are the angles? This angle and this angle, it has to be exterior, so outside. Then this angle and this angle are the alternate interior angles. Okay, and the last part, so these two are two lines, this is the transversal. Okay, then the angles on the same side, interior angles on the same side of the transversal are, these two are the interior angles on the same side of the transversal. Okay, one more, this angle and this angle, so these are interior angles on the same side of the transversal. Okay, So please go through the book, it is given there. Okay, please read those. They have given 1 and 5, 2 and 6, 4 and 8, 3 and 7 are corresponding angles. Okay, these are corresponding angles. Then alternate interior angles are, these are the alternate interior angles. Then alternate exterior angles are these all. Okay, and lastly these are the angles on the same side of the transversal. Okay, please read the textbook and try to understand. Interior angles on the same side of the transversal. Interior angles on the same side of the transversal are called co-interior angles or consecutive angles or allied angles also. So that you have to see. Okay. Now the first axiom, which is the third for the chapter, the third axiom. But first here about parallel lines and due to a transversal, angles created due to a transversal for a pair of lines. So what it says, if a transversal intersects two parallel lines, then each pair of corresponding angles are equal. Now understood? Now if a transversal intersects two parallel lines, then each pair of corresponding angles is equal. Now what it says, say these two are parallel lines. Of course you will have arrowhead. When you are drawing lines, please ensure you will. Okay, so these are parallel lines. Say this is M, this is N, and let it be L. Okay, now when a transversal intersects, this is the transversal intersects two lines M and N, then the corresponding angles are equal. So this angle equal. Okay, then we have this angle equal, corresponding angles whatever we have discussed before. Then we have this angle and this angle, this angle and this angle, the corresponding angles are equal. This is our first axiom. The other one, 6.4, is the converse of the previous axiom. That what was the axiom before and what we got, that if two lines are parallel, then their corresponding angles, okay, made by the transversal are equal. Now the converse is what, if a transversal intersects two lines such that a pair of corresponding angles is equal, then the two lines are parallel to each other. So if we can show, in case of two angles, if in case of two lines, when it is intersected by transversal, if a pair of only one pair, okay, corresponding angles is equal, then the lines are parallel. Okay, the converse. So here if you look at here, you will see this angle and this angle is equal, this angle and this angle is equal. It is about, this is not corresponding angles. Okay, these are alternate interior angles. These are alternate interior angles. Now we'll head on to this theorem. Now this theorem, so remember for corresponding angles it was an axiom, that is true statement. Now this is a theorem. Now what it says, if a transversal intersect two parallel lines, then each pair of alternate interior angles is equal. Okay, if you look at here, see, so this angle and this angle is what? A pair of alternate interior angles. And if this line and this line are parallel, then the alternate interior angles are equal, or each pair of alternate interior angles is equal. Okay, this is the theorem. The proof is given in the PDF. We just go through it. Okay, then we have the other theorem, which is the converse of the theorem 6.2. that means if we can show for two lines, when a transversal intersect those two lines, a pair of alternate interior angles is equal, then that two lines are parallel. Okay, then for theorem 6.4, if a transversal intersects two parallel lines, then the interior angles on the same side of the transversal is supplementary. Then those are parallel lines. Okay, then again the converse of this theorem, if we can show that the pair of interior angles on the same side of the transversal is supplemented and the two lines are parallel. Okay, one is the converse of the other. Okay, now what does this theorem 6.4 says? That when we have two lines, two parallel lines, okay, two parallel lines, and this is a transversal, then the angles on in case of parallel lines, then the angles on the same side of the transversal, that means the interior angles on the same side of the transversal, is supplementary. Now supplementary means, remember, the sum is their sum. That means when you add these two angles, their sum is 180 degree. And we have another also angle here, this angle and this angle are interior angles on the same side of the transversal, their sum is 180. It is for the pair of parallel lines, remember. And converse of it, what if we can show, okay, converse is, if we can show, say if we have two lines, this is one line and this is the other line, if we can show that this angle, only one pair, if we add these two angles, is equal to 180, that means it's supplementary, then this line is said to be parallel to this line, M and N. If they are 180 degree, then we can say M is parallel to N. This is the theorem 6.5, converse of the theorem 6.4. Okay, then we have another theorem, that lines which are parallel to the same line are parallel to each other. So here you are given, you see, here this line L, and say I'll read out this one, how they have given. They have taken this M is parallel to L, and L line N is parallel to L. Okay, so M and N are parallel to L. This M is parallel to L, and okay, this M is parallel to L, this N is also parallel to L. Now if according to this theorem, by this theorem, lines parallel to one another are also parallel to each other. That means we can show that this line is also parallel to this line. Okay, then we can show that line M is also parallel to line N. Say like A is equal to B and B is equal to C. We know from here A is also equal to C. Like that. Same way, say M is parallel to L, N is also parallel to L, then M is also parallel to N. Okay, this is what the theorem says. Then we have the angle sum property. We have the angle sum property of a triangle, and what it says, the sum of the angles of a triangle is 180 degree. Like if you have three angles A, B and C, so angle A plus angle B plus angle C equal to 180. This we have learned before, so it is not new to us. The proof I will give you in the PDF. You'll just check that one. Okay, now look at the other theorem, 6.8. what it says, if a side of a triangle is produced, then the exterior angle so formed is equal to the sum of the two interior opposite angles. Okay, this is one of the most important theorem for this chapter, and later on when you are doing some problems related with triangles, we will need this theorem. So please try to understand this and remember it properly. Okay, now say this is a triangle A, B, C. Okay, now what we are doing, we are extending this to D. When we are extending this to D, see, it is creating an angle. This is the exterior angle. This is itself the exterior angle of the triangle. We can have three exterior angles. How? If you extend this one, then we'll have here another one. If you extend on this side, you will have here. Okay, so we'll have three exterior angles. We are not going to discuss about all three. We will give for one, and you will understand how the theorem applies. Okay, so we are not going to discuss about the other two. So you remember this one. So look at here, this exterior angle is equal to the sum of the two remote interior angles. Now if you see here, this angle is adjacent angle, nearer, so we will not take this angle. We'll take the remote interior angles. Remote interior means the left are the what? This angle and this angle. Okay, so what we are doing, we are not taking this angle, so the remote interior angles will be this angle and this angle. So from here what we can see, we can see that the sum of this angle and this angle, if you add it, you will get this angle. Okay, so what you can see, so angle A plus it was angle B equal to, it was angle ACD. How it was? The triangle was like this. Yes or no? The triangle was like this, and the exterior angle was this one, and the interior angles are this one. So angle A plus angle B equal to angle this ACD. Okay.